Good evening, everyone. If I can have your attention, we'll move right along with the program. What an awesome night this is. What do you say? Looking out across the room, I can't help but think of Joe's comment about Joe's quote actually from the Colorado government employee about fitting all the world's skeptical scientists into a phone booth. I have to say I didn't know they made phone booths quite so large. Congratulations, everybody. It's wonderful having so many of the world's leading scientific experts here in one place. And as far as this being a rather large phone booth, you should have seen the number of PhD scientists and university professors that I had to, beat away with a stick. In fact, I probably went through about 10 sticks over the past couple of weeks trying to keep some of the world's leading experts in climate science, climate change economics, away from this conference. They certainly wanted to be here, and it's a testament to the expertise in this room, the number of people that are here. As most of you know, I'm James Taylor. I am a senior fellow at the Heartland Institute. It's been my pleasure to bring this group of people together. Thank you very much. The irony of the phone booth comment from the Colorado government official is that just 10 days after he made that remark about the phone booth, a Colorado Professional Engineers Association sought to sponsor a debate on global climate change and related issues that the public is so curious about. So they invited the governor's climate change advisor to give a presentation about the governor's climate action plan that was deemed to be so necessary for Colorado, for the nation, and for the world. Now, one of the world's foremost meteorology experts, Dr. William Gray, one of the world's, yes, absolutely. One of the world's foremost solar energy scientists, Dr. Howard Hayden, both of whom are here tonight, and I cheerfully accepted the invitation to appear at this conference to critique the governor's climate action plan, to discuss the underlying science. However, the governor's climate change advisor could not identify a single scientist to back up her claims about global warming and the supposed need for the governor's climate action plan. Indeed, the Colorado Professional Engineers Association went beyond her advice because she could not find any, so they went out and they tried to find leading scientists, leading proponents of the theory that humans are causing an alarming global warming crisis. And they also could not find a single scientist that would appear in such a public forum and subject their claims, their take of the science, to public analysis, to public criticism, to any attempt for anybody to question their take of the science. And as I think back to the empty chair that Dr. Hayden and Dr. Gray and I debated, and as I look across this room, I say to myself, at least we can fill a phone booth. Indeed, just like the professional engineers in Colorado, we have invited to speak at this conference many of the most vocal proponents of the theory that humans are causing a global warming crisis. True to the form they have shown in Colorado and elsewhere, and knowing that we would focus on science rather than on clever but scientifically flawed media sound bites, not a single one would come here and speak. Of course, they have reason to shy away from public debate. We often hear the assertion that the debate is over. Well, I have to say that on this count, they are indeed correct. 1 year ago this month, right here in New York City, the prestigious Intelligence Squared Debating Society hosted a scientific debate among some of the world's leading global warming experts. A pre-debate poll of the audience showed that the audience believed by a 2-to-1 margin, 57% to 29%, that global warming is a crisis. After each of the experts had ample time to present the evidence and debate the science, the audience was polled again. And this time, the audience voted by 46% to 42% that global warming is not a crisis. When people have the opportunity to hear the science for themselves, they are far more skeptical of the alleged global warming crisis. Yes, Virginia, the debate is over, and the alarmists have lost. No wonder they're so publicly afraid to come and discuss the science again where people can question their assertions. Now, had tonight's keynote speaker been a part of that debate, the verdict would have been even more emphatic. Indeed, it is a direct result of our speaker's research and writings that I and many others have come to understand the scientific flaws in the theories that humans are creating a global warming crisis. 15 years ago, while I was in law school, like many other folks, I was convinced that global warming was indeed occurring, that humans were causing it, and that we had a crisis on our hands. So I decided to do something about it. I proposed writing an article for the local school newspaper in which I would research the science, report on it, and then show people what they could do to avert the oncoming global warming crisis. But a funny thing happened when I began digging deeper into the facts. Early in my research, I came across a book entitled Sound and Fury: The Science and Politics of Global Warming. Here, a climate scientist with impeccable credentials presented a mountain of evidence that the effect of carbon dioxide emissions on global climate were being overstated. The science presented in the book was sound, and it led me to begin digging deeper into the scientific journals. The more I researched, the more I realized that this science was right, that this scientist was telling the truth. I had been an impassioned believer of the coming climate crisis, but tonight's keynote speaker had shown me, and has shown thousands of others, the real scientific truth. Tonight's keynote speaker, a research professor of environmental sciences at the University of Virginia, and a past president of the American Association of State Climatologists, went on to publish a series of books documenting the ongoing advances in global warming science. With each passing year, his scientific assessments regarding global warming become more irrefutably supported by real-world climate observations. He is widely published in the world's leading scientific journals and has the gift of making the science understandable on the evening news programs and in the pages of the nation's leading newspapers. He is a contributing reviewer of the United Nations Intergovernmental Panel on Climate Change. He was an author of the Climate Paper of the Year awarded by the Association of American Geographers in 2004. According to Nature magazine, he may be the most popular lecturer in the nation on the subject of global warming. Ladies and gentlemen, it is my distinct pleasure to introduce to you Dr. Patrick Michaels.
Thank you. Thank you. Thank you very much. It's an honor. It's an honor to speak to such a group, and I cannot tell you how my heart is swollen with pride as to be here. I'd like to talk to you about some convenient facts on global warming, if I could. And I'm going to move away here some because I'd like to use the laser pointer at the same time. One of the things I want you to understand about this issue, forward, there we go, is that climate does change, okay? We can't go denying the reality that the planet is warmer than it was. Here's a fine example. This is from the first book ever written on the subject of climate change and human society from the modern perspective. It was called Times of Feast, Times of Famine, Climate Since the Year 1000 by Emmanuel Laudruy. And it shows this glacier here. This is the Argentière Glacier. Here's the little village of Argentière. And there are many scientists in this crowd, and they're all amateur geologists, as every scientist claims to be. And you can see this gash on the side of the mountain that was surely where the glacier left a lateral moraine during the height of the last ice age, about 14,000 years ago. And in the book was a woodcut from 116 years before. And what do you see? I have a question for you. What are these people praying for in this church? This glacier is coming down the side of the mountain. It's moving forward. God helps those that help themselves. Oil was discovered just a little bit before that, I believe in Oil City, Pennsylvania. We developed the internal combustion engine. Carbon dioxide went in the air and the planet got warmer. So they got their wish. Now, okay, first of all, don't go around saying the planet's not warmer than it was. In this talk is going to be like an Evelyn Waugh novel. It's going to have something to offend everyone, okay? So just get ready. This is the Intergovernmental Panel on Climate Change's surface temperature record. I am a member of the IPCC, proving that all garden parties need their skunks. However, due to the laws of supply and demand, the skunks fly in the front of the aircraft. Anyway, there are in fact two distinct warmings here. There's a warming of the early 20th century, which is certainly more likely to be solar than anything else. And there's a warming of the later 20th century, which has some very, very interesting characteristics. Namely, it goes backwards when it's supposed to go forward, that it warms up the winter more than the summer. This is the winter temperature change since 1977. That second warming of the 20th century started around 1976, 1977 with something in the Pacific Ocean that no one yet understands. It's called the Great Pacific Climate Shift. There's a jump in temperature. And it wasn't discovered until 20 years after it happened. Now, it's summer here in the southern hemisphere down here. You don't see nearly as much warming. In the winter, you see a large warming in the northern hemisphere. And here in the southern hemisphere, you see the warming attenuates here in the northern hemisphere in the summer, which is what's predicted by greenhouse theory. And in the southern hemisphere, where it's winter when it's summer here, you can see that there's some warming down there. Fine. So, global warming is real, and the second warming of the 20th century, people have something to do with it. All right? Now get over it, okay? Now that you're all mad that I said that, that really tells you nothing. You care not a bit how much human beings are warming the planet, or if they're warming the planet. You care about how and how much. And we will see by the end of this talk that nature has tipped his, remember I work at a university, hand on this issue, and will tell us, I think with some confidence, how much it's warmed. Now, just to make sure that I've got your attention, you've all seen articles saying that global warming stopped in 1998. Well, with all due respect, that's being a little bit unfair to the data. This is 1998 here, and it was a huge El Nino year. And the sun was very active in 1998. And so what you have, you're going to have the fall off here in temperatures, either surface temperatures, either satellite temperatures, as the consequent La Nina, the bubbling up of the cold water that was trapped down there by El Nino, takes place. Howsoever, please pay attention to this chart because it tells us so much about the future. This is the warming through 2005, and I have a feeling that somebody's got my other presentation on here, but that's okay. If we take 2006 and 2007, we'll see 2 points over here, and the line fits actually quite well. The warming rate has remained fairly constant at about 0.17 degrees Celsius, almost ever since it was established. Now, what I'm going to do is I'm going to test the hypothesis as to whether global warming has stopped. Because I want to tell you something. Everybody in this audience, make an argument that you can get killed on and you will kill us all. Okay? I think most people in this room are of the conclusion that global warming may be an exaggerated issue, but if you lose credibility on this issue, you lose the issue. These are two temperature histories. The top one is the surface temperature from the IPCC, and Ross McKittrick is going to have a lot of fun with that tomorrow morning, showing you what's wrong with it, a paper we did. And this is the satellite temperature here since 1979. And we're going to ask the question. There's a warming trend in this data, which you can see. Did that really stop in 1998? And I'm going to make two assumptions. First of all, I'm going to explain the warming or the temperature behavior with four factors. El Nino, called ENSO, volcanoes, solar variability, and warming itself. And I'm going to ask the question, do the last years in the record fit the data if we assume there's a warming trend better than if we assume that warming has stopped? Well, there's your answer. Here is the assumption that global warming continued. You can see how it fits the background data much better than assuming global warming has stopped. What's happened? What's happened, and this is why this argument is so very, very dangerous, is the solar activity and the El Nino, the La Nina we're in now, have conspired to add up to produce very, very little temperature change in the last couple of years, in the last few years. And so what's going to happen, one of these years, that's going to turn around. And if you make that argument now, you're going to have a very, very difficult time defending the future. Whoops. Now, why is the news on global warming always so bad? Here is a bizarre little analysis for you. I'm going to read this quote because it was written by a group calling themselves the climate scientists, and they wrote a brief to the Supreme Court in the Mass v. EPA case. Jim Hansen, Alan Battisti, all the names that get in all the newspapers. You know, Jim Hansen, he's a scientist who works for NASA who says it's being suppressed. Google Jim Hansen on global warming, you'll find he beats the next best guy by about 10 times or so. Anyway, they wrote this. Outcomes may turn out better than our current prediction, but it's just as possible that environmental and health damages will be more severe than the best predictions. What does it say? Just as possible that new scientific results will make global warming seem worse than we thought or not as bad as we thought. It's the same thing with weather forecasting. Every day we send up weather balloons, twice a day around the planet, and they're input into a computer model. It has an equal probability of raising the forecast for tomorrow's high temperature or lowering it. And my scientific colleagues feel that this is also the case for global warming. I thought this is one of the most peculiar things I've ever seen in my life. The weather forecast models are unbiased because of the mathematics in them. Scientists may be biased because of the mathematics in their bank account. Let's ask the question. So what I'm going to do here is I'm going to look at 13 months of Science and Nature magazine, and I'm going to take all the global warming articles they have, and I'm going to throw them into one of three piles. It's worse than we thought, it's not as bad as we thought, or the article's neutral, or I can't tell. And I found 115 articles. Let's just look at the not as bad as we thought versus it's worse than we thought. 9 were not as bad as we thought, 83 were worse than we thought. That's like flipping a coin 92 times and getting 9 or fewer heads. Do you know what the probability of that is if it's really unbiased? It's less than 1 followed by 10 and 16 zeros. And why is this? Okay, first of all, conclusion. What's happening is the information stream that's coming out of the most prestigious journals that we have, Nature and Science, hardly obeys the prediction of the climate scientists. That is a 50-50 chance or an equal probability that the new news will be good or bad. It's hardly the case. And think about it, why should it be the case? If I submit an article to Science, I submitted one to Nature, Bob Davis was the senior author, showing that people, this is going to shock you, as there are more and more heat waves, people get used to them and fewer people die. Well, Nature had been publishing articles all over about heat-related deaths increasing, and they declined even to send our article out for review. That was the one that won Climate Science Paper of the Year eventually. But that's the point, is that there's a real threat from an article that says this is not the end of the world. Remember, global warming is real, but that is not the point of this discussion. The point of this discussion is what will it do in the future, and can you do anything about it, and should you do anything about it? It's not whether or not the planet is warming. If I write that this is not that much of a threat, the average reviewer that it goes to, seeing as there's $6.2 billion per year spent on global change research, is going to say, this article's a threat. And so it's going to get a pretty rough review. Fine, I'm a big guy, I can take that. I'll get it published eventually. But if I write an article that says it's the end of the world, it's going to get a really smooth and easy review for the same reason. That has a very interesting effect. The articles that say it's the end of the world are so easy to tear apart, a high school student can do it. And the articles that say that it's not as bad as we thought are very, very hard to tear apart. So you have two consensi, if you will, and the one that has the fewer publications has gone through more rigorous review. And that's why it makes such a compelling picture. Okay, now for the fun part of the talk. Hi, I'm Al Gore. I'm just like you, only better. Anyway, and when I put my hands on my chest to emphasize a point, I'm lying. Is Antarctica melting? This actually is from Gore's book. It's the Antarctic Peninsula, and he says each orange splotch represents an ice shelf the size of Rhode Island that is broken up, and he actually put some perspective in it. Thank you, Al. I really appreciate that. Here's Antarctica, and there's the Antarctic Peninsula. He showed you this was a very small portion of Antarctica, but he didn't bother to show the temperature history of Antarctica. If you take a look at the colors on this scale, you'll see that they're green to blue over the continent of Antarctica. Yes, there's warming right here in the Antarctic Peninsula. Do you know why all the research comes out of the Antarctic Peninsula? It's because it's the only place that's slightly comfortable. Nobody else wants to work anywhere else in Antarctica. And consequently, we get a lot of work there where there's a lot of warming. But the net temperature change is, in fact, negative or neutral. Now, this is one of the papers that has started the Antarctica is disappearing craze. It's from Science 2 years ago. It's the first paper from the GRACE satellite, which measures gravity, and that's translated via 15 equations that all have large error terms into how much ice is gone. And I'd like you to take a look here, first of all, at the first data point. And what you'll see, it's in year 2002.5, and it's very, very far separated from the rest of the data. Now, if I were as big as Gore, I could stand up and cover up these 2 points, but I can't quite do it, and it's a rear projection screen, so it can't do it anyway. And what you can see, if you take away the first 2 points, which are far separated in time from the other ones, is that trend really begins to fall apart. Now, there are other ways of measuring ice in Antarctica. Here's East Antarctic ice sheet from Davis in 2003, and I'd like you to follow my red laser pointer to look at where the record started from the satellite. 2002.5, right there. If it hadn't gone down, I'd be surprised. Now we have records of how much the ice is above or below normal every year, taken by satellite since 1979 in Antarctica. And yes, this is not a misprint. Here it is bouncing around plus or minus 1 million square miles or so. Right now, as we speak, the ice in the southern hemisphere is expanded at higher, greater extent than has ever been measured by an orbiting satellite. Where's the news coverage? I see very little on this. But the fave story is Greenland. You see, here's the mythology. Greenland warms up, the ice, the water runs underneath the ice, and the ice sheet is sort of lifted off, if you will, sort of like shaving cream underneath it, and the ice falls into the ocean, and yes, the sea level rises 23 feet or 6 meters. And that's right, Gore didn't say that. He just had pictures in his book of that happening in Florida. I'd like to talk about Greenland. Here it is. It's an inconvenient truth. Read it for yourself. These photographs from Greenland illustrate some of the dramatic changes now happening in the ice there. Well, the Danes left behind a really nice network of thermometers. And this is a record that goes back to the late 18th century, believe it or not. What you see here's the current era. And look at wait a minute. This is from 1915 to 1960 or so. And clearly the mean decadal temperature is warmer than it was in the last decade. What on earth was happening? Oh my God, the water is flowing down underneath the Greenland ice cap and detecting ice. Anybody know how much ice is being lost on the average? The last paper in Science magazine I saw per year from Greenland? 25 cubic miles per year. Whoa, that's a lot, except there are 690,000 cubic miles. It's losing ice at the rate of 0.4% of its ice mass per century. I didn't say 0.4% per year or per decade. I said per century. It takes a long time to get rid of that. And look at this. Here's a picture of a river on the Arctic ice. Chip Knappenberger from my company in Charlottesville is here today. Chip is a wonderful, wonderful employee. He finds stuff like this. That's what you pay the big bucks for. River disappearing in 40-foot deep gorge. This is from a source, CATS HR, A Journey Across the Nunataks of Central East Greenland, published in 1953. Whoa, that's interesting. My favorite one. Okay, ladies and gentlemen, this one you might actually be impressed with. You've seen Warming Island. This came out a year ago in the New York Times. A peninsula long thought to be part of Greenland's mainland turned out to be an island when a glacier retreated. The implications were not lost on Dennis Schmidt. Dennis Schmidt started the cult of Warming Island. It's a cult. Go look it up online. It's phenomenal. Warming Island. Let's bow down to Warming Island. And so they named it Warming Island, and it's supposed to remind people of the horrible, horrible things from global warming. Okay, now here's why it was thought to not be an island. This is a standard reference map of Greenland. And you can see here's this place called Carlsbad Fjord. We're looking here in eastern Greenland. And you see this peninsula here with these three sort of fingers on it. And here is the a satellite view of the fingers, if you will. You can see 1985, it's connected to the mainland. Yeah, bridge is getting a little thin. The water's open by 2005. Voila, warming island. Here's a side view of warming island. Now let me ask you that question. We have this temperature history. This is the nearest weather station, Angmasalik. If somebody can tell me how to really pronounce it, I'd like to know. Here's the last 10 years. Here's that period in the early and mid-20th century that was just as warm or warmer on decadal average. I have a question for you. What happened back then? Well, Chip, diligent as he is, found a wonderful book called Arctic Riviera, published by Ernst Hofer, an aerial photographer who did support work for the expeditions in eastern and northeast Greenland. And in Hofer's book is a map. Northeast Greenland, let's look a little closer. Oh, it says Carlsbad Fjord. Wait a minute, that's an island. That's right. 50 years before, it was an island. Not 5,000 years, not 500,000 years. 50 years before. Nobody even bothered to check. And the cult arose. And this is what is trotted in front of the US Congress, the House and the Senate, as the reason that we have to reduce our emissions 60%. God knows how much that'll cost. Because islands are appearing. Warming Island has appeared. Well, it was there. Here's a real complicated chart. This is real good to show to people after dinner. It's time in thousands of years before present. And there's a word here called Greenland. And there's a big red splotch. It's from the United Nations latest report. It says above pre-industrial temperature by 2 degrees C or more. Let's see, that goes from 7,000 to 10,000 years ago. That's almost 4 degrees Fahrenheit warmer than the pre-industrial temperature. Let me tell you where that comes from. It comes from a paper by Glenn McDonald, who's the chair of the geography department at UCLA. And this is a tremendous understatement by the IPCC. Somebody should have really held their feet to the fire. The paper says July temperatures were, I'll do it in Fahrenheit, just a little bit less than 4 to 13 degrees Fahrenheit warmer during this period. Actually, the period was longer than it is now. Why? Trees fall at the edge of the tundra. The tundra is very acidic. They're preserved. You can carbon date them. They went all the way up to the Arctic Ocean here. This is the Eurasia right here, where this is the Arctic sea ice extent from 1979. I'll get to that in a second. The tree line went all the way up to here. Now it's about 100 miles down. And there are islands here in the Arctic Ocean. And you dig into the tundra there, and you'll find trees. So you know how warm it has to be in the summer for the trees to survive. And that's how warm it was. Now, answer me a question. How do you get all that warm water into this Arctic Ocean? Well, you can't do it through the Bering Strait. It's not big enough. You have to take the water through the strait between Greenland and Europe. So what does that mean about Greenland temperatures during this several millennia period? Did all the ice fall off of Greenland, never to be replaced? No. By the way, this is the Arctic temperature history. You just saw that picture I showed you. That was for the first year of the satellite record for Arctic ice. Would a federal agency actually not tell the whole story? I cannot believe that. I must be a cynic. That record starts in 1979. This is the Arctic temperature history. Ice melts in the summer. Oh, 1979 is after the end of the coldest period of the 20th century, until we go back to the early 1920s. So if the ice was not dramatically expanded when that satellite first started returning data, that would be very, very odd indeed. And then we go to 2005, and you can see here the recession of the ice from the Eurasian sector. Answer me this. If it was 4 to 14 degrees Fahrenheit warmer in July for much of those millennia, where do you think the ice was at the end of summer then? It wasn't, okay? It wasn't. The polar bear survived. The Inuit culture radiated. Enough said. Thanks. Now, finish this talk with a little discussion of human intelligence. This is about people dying, okay? If we take a look, there's what's called a theory that as our cities get warmer and warmer, there'll be more and more deaths from heat-related mortality in our cities. And it comes from data like this. This is New York City right here. This is the 4 p.m. apparent temperature. That's a combination of temperature and humidity that northerners use like southerners use wind chill, just to make us feel worse than we really are. And what you can see here is actually mortality declines as one apparent temperature goes up. But there are certain days, particularly at the beginning of summer, where, whoa, look at all these deaths. And in fact, if you warmed up the temperature of the city core by 4 degrees or so, the number of deaths should be on the ceiling. That's called the stupid people hypothesis. That as the city slowly warms up, cities slowly fry and die in the city. That there will be no incentive for people to sell a technology that might afford them comfort and life. There will be no response from the political community, like there was in Chicago in the mid-1990s when 500 extra bodies showed up on a weekend. And about 3 years later, there was a heat wave of similar magnitude. Very few people died. But that is a stupid people hypothesis, and setting this one up as a test is really sort of kind of a dumb thing to do. I went to Bob Davis, who's a senior author, and said, Bob, why are you doing this? They're never going to publish this. The thesis of this paper is people don't want to die. He said, you'll see. Look at Houston. Houston is a modern city, more modern infrastructure. You don't see any of the death spikes in Houston. Have any of you ever been to Houston in the summer? You have? Why? Why on earth would you do that? Anyway, so the hotter it gets, they just don't die. They are living in an air-conditioned environment. And in fact, if we take a look at heat-related mortality in our major cities, it's going down. Whoa. Why? Because people get used to it. We could even draw a map with these little histograms on it. You can see these are the 3 decades for which we have data. One of the things that's really cool about this is the first thing you notice is, you know the story. It gets hot, and the elderly and the debilitated die, okay? So let's take a look. My God, does anybody know the age structure of Tampa? There are no deaths there. Not at all. You go looking for a young wife or husband in Phoenix, you're going to look quite a bit. So the point of the matter is that the hotter it is, the fewer people die in the heat. Now, you can make your own value judgments on this, but there is no one city on this map where it's actually going up, and that's in Seattle. Now, Seattle happens to be the coldest city in the summer on this map. Oh my God, I hear the undergraduates in the crowd shrieking, oh, but Dr. Michaels, all you're doing is you're moving heat-related mortality northward. You're exporting it to Canada. Follow the cursor. This is 60 degrees latitude. There are no cities in the world basically above 60 degrees latitude unless they're put there by very unusual climatic situations like Murmansk or Archangel or some of the Scandinavian cities, or they're prison camps. Sorry. So what we do, we are actually squeezing heat-related mortality off the map by warming up our cities. All right. Now, this is the cool part, okay? You gotta follow this part. How much of that $6.2 billion pie would exist if I said, you know, we really know how much it's going to warm? To a pretty small range of error. And by the way, it's not that much. Okay, how? Well, it's been known since about 1870 that the responsive temperature to a change in a given greenhouse gas is logarithmic, meaning the first increments go up like this, and then it begins to level off. So it never completely levels off, but the first increments create the greatest warming. And we'd like to assume the carbon dioxide is going in the atmosphere in some sort of exponential form. It's a very slight exponent, but it is now an exponent. It wasn't for about 30 years when it was supposed to be. So CO2 is going to go up like that. The response to CO2 is like that. You add up this curve and that curve, and you get something that looks like a straight line. In fact, that's what you get from your computer models. This is from the latest report of the Intergovernmental Panel on Climate Change. It's a bunch of different computer models. Each thin line is that spaghetti, forms that spaghetti plate. The solid line is the average of the models. I'd like you to convince yourself that this is saying that once warming starts from human activity, it takes place at a constant rate. Sure looks that way. And so, maybe we ought to ask the question, is the warming been at a constant rate? There's the temperature change. That's the 05. I should put the 07. My apologies. I slipped the wrong graphs in here before dinner. But anyway, the rate is constant as constant can be. And it's between 0.16 and 0.17 degrees per decade. And it's been constant for quite some time. So that tells you how much it's going to warm. Unless all those computer models are wrong. unless all that research is incorrect. This is the mid-range emissions scenario, by the way, for the United Nations. It's the sort of the reference scenario that tends to be used quite a bit. Unless all this research is wrong, you see the models just produce warmings at different slopes. They have different rates of warming in them. If you have a weather forecast model, and a bunch of models, and one of them says it's going to rain tomorrow and the other one says it's not going to rain tomorrow, what do you tell the students? Look out the window, okay? Which model performed best in the last few days? Which model performed best in the last weather situation that was like this? What do you tell the climatologists when you have a bunch of different models all predicting constant rates of warming or tending to predict constant rates of warming? Look out the window. This is the window, okay? Now, what do you propose to do about this? That's the other question. We can't just go on doing this forever. We can't continue to put carbon dioxide in the atmosphere forever. We must do something about it. Well, let's see what happens when you try to do something about it. This is another version of that previous chart in many ways. What you have here, this colored spaghetti, is something called a coupled model intercomparison project. And this, for the ground rules, is to take different computer models and see how they behave together. The carbon dioxide has increased at 1% per year in these models. The reality is that in the last decade, it was about 0.49% per year, something like that, 0.39, 0.48 in the previous 2 decades. It's been pretty constant, and it's around 0.5% per year. It shouldn't shock you that the models tend to predict too much warming. But anyway, they are linear, and this is what you get for the linearization of the observed trend. Now, the solid black line is the model average. The dashed line is the model average if every nation of the world did what they said they were going to do under the Kyoto Protocol. Every nation of the world that had obligations lived up to them. And what you see here in year 50, you can't almost see the dashed line because it's only 0.07 of a degree Celsius underneath the solid line. Every scientist who studied this knows that. It's not a matter of controversy. 0.14 of a degree by year 100, but the world didn't do Kyoto. So therefore, we need to reduce our emissions 5 times what was mandated in Kyoto. I'm sure that'll happen. Well, it certainly could acquire the force of law here in the United States, and we have a court system that likes to enforce these things. You could wind up with exceedingly expensive energy. And as my take-home lesson, I'll show you where that could or could not get you. This is a graph, the last 5 years of the share price of, of Toyota, Honda, General Motors, and Ford. What you can see over the course of those 5 years, prices have dropped a little bit recently, is people were taking their money in their retirement accounts, and other people were investing in companies that they thought produced things efficiently or produced efficient things, and taking it away from others. Now, the perceptions may not be equal to reality, but they are very, very good at creating this impression. And so what happens if you take away my money? I cannot invest it in the future. It's gone. Anybody want to see how it goes? Anybody want to see how it goes? Think of what the political response has been to global warming with the energy bill of 2005. And it was this. Ethanol. We're going to produce, the original energy bill mandated 700 million gallons a year. That's been ratcheted up to now, I think, 34 billion gallons a year by the year 2021 or something like that. Last year, we diverted 33% of our corn crop to ethanol. We produce 54% of the world's corn. 33% of 54% is a lot of food, and it's a lot of food that people didn't have, driving up the price of food. I can name you 5 separate food riots in the last 6 weeks around the world. Riots because of the cost of food. What we have done is we have become the first nation in the history of the planet to burn up its food supply in the name of political correctness. And that's the problem with jumping off the bridge with policies that will accomplish little or anything on global warming. You will take away the money that belongs for investment in the future. Take this home with you, okay? The future belongs to the efficient. Thank you very much.